Good morning. Today I will talk about the Hadoop. I will major introduce the Hadoop. The first thing I want to talk about is what's Hadoop. In fact, Hadoop is an open source software framework for storing data. That's the first thing, storing data. The second thing is also is running applications. So there are two functions for Hadoop. One is storing data, another is running application. Application here generally means software or some programming some people wrote. But here is, we most emphasize is it's class of hardware. It's a class of computers, not just on one computer. Okay, a lot of computer to construct a cluster. We use this cluster to store data in the running application. In fact, Hadoop provides massive storage for any kind of data. Also, enormous processing power and the ability to handle richly limitless concurrent tasks or jobs. In fact, from these things we could understand, because for big data, it's the volume is very large, so Hadoop can provide massive storage for this kind of data. That's the things. If you talk about the running application, it provides enormous processing power because a class of computer can be very, very big. You can add one, add two, add 100 or 200. So it's much stronger than one computer. Okay. Another things we talk about the task and jobs is not just the work on one job or one task. It can handle a lot of tasks. For example, you have program can process many files at the same time. So this is from the general idea, what's the Hadoop mean. Hadoop history. In fact, the development of Hadoop has a history. This just shows the which year what they have here. Okay. Originally, in fact, the Hadoop originally from the Notch. Okay, Notch is an open source web search engine. That's a long time ago. Okay, in fact, it was developed by Cutting and Caffrey. The aim for the Notch, they want to return web search result fast by distributed data and calculation across different computers. So multiple tasks can be done at the same time. So that's the original idea for Notch. But then in 2006, Cutting joined Yahoo and take him with the large project. And also, they try to bring the idea from Google's own work about automating distributed data storage and processing. Okay. After Notch was brought into Yahoo, then the large project was divided in two parts. One part they call the web crawler. Okay, that's remained as large. But the distributed computing and processing portion become Hadoop. If you guys want to analyze the result for a website, generally we can use the web crawler. That's a very famous project also. In fact, there are many research also on the web crawler. But another seems part from the large, the distributed computing and processing portion, they try to become to Hadoop. That's named after Carter's Sam's toy elephant. So that's the Hadoop originated from. In fact, in 2008, Yahoo released Hadoop as an open source project. So currently, you guys will find the Hadoop's framework and its ecosystem are managed and maintained by Apache Software Foundation. So you guys will know the Hadoop software you can download from this website. So what Hadoop can do? The first thing is Hadoop, we know Hadoop is designed for big data processing. Especially it's good for data-intensive text process. For example, you have many text files, okay? And also they have the same format. So we can use Hadoop to process these kind of files. The second is they also can good for the video and image processing. For example, for face recognition, face searching. If you have million people's face, you want to find the face you want. You can use Hadoop to search the big database, then find the matched. Also, it's good for graphic mining and large-scale social network analysis. For example, you can use for the Facebook analysis. Also, it's good for machine learning and data mining. Okay, that's Hadoop can do. Also, there are a bunch of multimedia information process and retrieval. From these things, we can do also almost the Hadoop can do anything. Okay. So who is using Hadoop? The bunch of company is using Hadoop. For example, eBay, Facebook, IBM, okay, JP Morgan, Chase, Twitter, Intel, Visa, Yahoo, Samsung, okay, Amazon. The bunch of companies that use Hadoop. So if you guys are very good on this course, I think you can find a job in this of famous company there. Okay. So one question you must want to know why we developed the Hadoop. Okay. What consideration needed to its design? That's the first question. So the second question is what were the limitations of only large-scale computing? And what requirements should an alternative approach have? That's the first step. Three things we want to ask. The first question is how does Hadoop address those requirements? Okay, let's think about this issue. The first things I want to talk about, we already talked about, is that Hadoop is designed for big data. Okay, so how to process the large-scale data is the major things when you develop Hadoop. As we talked about last time, there are many big data issues in different companies. They have big data. How to process this data? So Hadoop provides a framework. Think about this one. If the data is very big, if we use the single core computer, that's not enough. You must make a very, very strong single core computer. Can you do the big data stuff? Generally, the single core computer with very, very strong power is very, very expensive. Generally, it's for scientific research, they will use that one. So generally, that's not good. So that's the reason the single core computer, they developed to multi-core computer. If you guys check your computer, currently your computer has 4 CPU. Okay? But long time ago, just one single core computer. Also, another thing is from CPU to GPU. I'm not sure you guys know GPU or not. GPU called graphics processing units. CPU is computer process units. But the difference between GPU and CPU. So some things you can do, if you do use CPU, that's very slow. However, if you use the GPU technology, you can make it very fast. That's for this one. For the first two, we just talk about one computer, one machine. Okay. However, there is another computing framework. That's called distributed system. Distributed system, that means not just single machine. The bunch of machine, okay, is a cluster of machine. You have 100 machine, 200 machine. Not just one single machine with multiple core or with GPU. We talk about distributed system. Distributed means the many machines, then you collect by network. Then you do some work. Then they can do the work parallel. Okay, that's called a cluster-based computing. We call it distributed system. So, single core, there are big limitations for single core. Sometimes if you want to use a small computer or computer with small power, that generally can be satisfied requirement. Okay, that's first thing. The second is scalability also is an issue. The issue is like this one. For one computer, if you want to do something, it's okay. But if you want to do many things, okay, scalability means that if you have more work come here, I still can do. For the distributed system, that have the scalability. For example, I have 5 computers, we can do something. But if you have more tasks come here, we can add one computer there to make to 6 computers. Then you can do the new task. Okay? If you have more tasks come here, we can add more computer there. Then we can do more. That means the scalability is very good for distributed systems. Okay? So for the distributed system, there are many benefits. For the scalability, it's just one. Also, think about the another things. If when you do some task, if one machine is failed, then we can use other machine to do the same task. But for single core computer, sometimes if the one machine is crashed, then the whole task you cannot do. So that's another benefit for the distributed systems. So how to introduce the development of the Hadoop? First, we need to understand in order to do that in order to process big data, there should be some requirements for a distributed system. The first thing is we call fault tolerance. That means if one component, one computer fails, it should not result in the failure of the entire system. It's not like a single machine. Think about this one. It's a single machine is crashed, then you cannot do anything. Also, in the distributed system, you have 100 computers are connected with each other. If one computer failed, they should not affect the whole system. Okay, that's the important for the distributed system. When you design you need to think about these points. If one field if affect the whole system, that's not a good distributed data system. Okay. The only thing is if one field, one component field, the performance perhaps is degraded. It has no performance, but it does not affect the failure of the whole system. Another thing is if the failed computer or components just will come back, it still be able to rejoin the system. So that's the requirement for the fault tolerance for the distributed system. That's the first requirement when you design this kind of systems. Okay. The second is about the recoverability. Recoverability, that means if there is some event happen, it's failed, but the data will not lost. Okay, you must have this make the machine, make the distributed system have this mechanism. This just show a distributed system. Just collect many machines. Okay, how to collect them? You can use cable. It's a network. Okay. So another thing we call consistency. That means one job, one task will not affect the final result. That means if you have a bunch of tasks, jobs running there, but if it's one fail, we still get the final result, correct result. How to make the distributed system have this mechanism? Also the requirements for your design. The simple way like this one. You can make two machines to run 2 or 3 machines run the same job or same task, so that if one failed, we still have other 2 run it. So we still get the final result. So that's one thing you can do. Okay. Also, that's what we talk about the scalability. Scalability that you can add one machine or remove one machine. Add one machine, you can increase the performance of the cluster. Or remove one machine, you just reduce the performance, but will not lead to failure. So that's the scalability requirement. See here, that means we can add one machine or remove one machine from the cluster. Okay, that can make the performance not change too much, will not cause the failure. Currently we have 1, 2, how many machines here? 8 machines. Okay, for example, we can this one is gone. We have 7 machines, so that means we still can do the same task. The only thing is this system just the performance is low than the system with the 8 computer. Okay, you can add, you can disconnect this machine. It doesn't matter. Okay, it does not cause failure. It only affects the performance, make it the performance low or high. So in design the Hadoop architecture, they already concede the above requirements. They through several abstract concepts. Okay. The first concept for the Hadoop architecture, they just distributes the data across class loads. The concept of loads here means a computer. Okay. For example, we have 8 computers here. Then each computer we call the one node. That's concept that you guys need to know. Okay. So we have 8 computers here. That means we have 8 loads. So the first thing is I want to distribute the data across the cloud nodes by splitting it into small blocks. Okay. Every node try to work on individual block stored locally. So data transfer is required during the processing most of the time, not too much. That means I distribute the data across different machines. Okay, different machine try to use the and process the data stored in its local node. Only when necessary, I will get data from other node. One benefit for this design is can save the bandwidth, save the time. Okay, save the time to transfer the data from one machine to another machine because I try to use the local data. Okay, that's the first abstract concept. So another sense, because we talk about if one machine is failed, then with the performance that just is reduced, but they will not affect failure. How to solve this issue? In Hadoop, they use this concept. That means the data is distributed across nodes, and each block of data is replicated. That's an important concept. I store the data, same data, in different machine. Okay? In different machine. So even one machine is crashed, I still get the same data from other machine. Okay? That's make it satisfies the requirement for the distributed system design. So that's very important concept. Another thing, if a load fails in between, the master load, you guys will know what's the master load in the future, okay? Will detect the failure. Because one computer is failed, I still want to make the task go on. So definitely I need to find other machine who can do the same task. Okay? Also, where the rubrica of the same data block is available. So that's another concept. Also, if the load failed load restart, it automatically joins back to the cluster. And also, the master can assign a new task whenever it's required. That means there is one component failed, then I assigned its job to other machine. But when this failed computer rejoin me, I still can assign the job to the failed load, which is already recovered. That's another concept. Another thing we call concept is called speculative execution. Speculative execution, that means if for some machine, okay, it's slow, then the system can find some fast machine to move the task from the slow machine to fast machine to make the whole processing to be fast. So this also is the design concept in Hadoop. For example, you have 8 machines. There is 3 machines can do the same task. But currently, I just use 1 machine. But that machine is very, very slow. Then I can find another machine to replace the slow machine to make the whole processing to be fast. Okay? That's the 6th concept. The 7th concept in Hadoop is they will write in high-level language like Java and Python. That's most important things. because it's a low-level language, then make the programming is very difficult. You guys will know. So for the Hadoop, generally, you have some basic Java and Python. Then you can write a program. You don't need to go to deeply write some network program. You guys know, if you go to the library, you found there are 2 very, very thick books on network programming. That's very difficult. Okay, so that's the 7th concept. Based on this concept, in fact, they developed Hadoop to satisfy the requirements as a good distributed system. So after designing Hadoop, you guys will know Hadoop mainly have 2 components. One is called HDFS, another is called YARN. For the HDFS, the full name is Hadoop Distributed File System. For this one, this framework is responsible for manage data stored in disk across the cluster. That's major similar to some database, okay? But it has also have a management system. But this management system is not just saved in one machine. It's across the cluster. How to manage the data. Okay, that's called use the HDFS. Okay. Another part is called the YARN. In fact, the YARN only come on the new version of Hadoop. In the old version of Hadoop, it does not have YARN. YARN only exists in Hadoop 2.0. Hadoop 1.0, it does not have YARN. YARN acts as a cluster resource manager, allocating computational assets. For example, YARN can be found which loads is available for run some application, for processing some data. Also, the availability. Okay, another is memory. What kind of memory I need to assign to some application? So there are 2 main components. But on the top of them, these 2 main components, there are other framework. For example, you guys know there is MR, Peak, HAR, others, Stream, Graph, and Service. For example, there are Hubase. This is just based on these 2 basic components. We build this kind of other framework. Okay. But currently, what you guys will learn is YARN and HDFS. We put 2 here because it's the major use for the version 2. Okay. I already talked about the Hadoop framework. In fact, the Hadoop framework, in fact, is not the hardware. It's just a framework. Okay. It's a framework of or a piece of software that's run on the cluster. A cluster, you can just, you guys know, for cluster, you can just a collection of many computers, okay, collect them together. They can view as a single system. Definitely, you need some software to regulate the whole computer cluster. Hadoop is one of this kind of software, okay, to regulate the cluster. How to make the data to store on this cluster. Also, how to make some application run on the cluster, not run on the one computer. You write some code, it will run on the whole computer cluster. So Hadoop is like this way, okay? What kind of we call the Hadoop cluster? We can say, oh, computer cluster regulated by Hadoop framework or Hadoop software. Then we call Hadoop cluster. Okay, so that's the basic concept for the Hadoop cluster and the compute cluster. Hadoop cluster is a computer cluster, but a computer cluster is not a Hadoop cluster. Perhaps a computer cluster is another regulated by other software or other system. Then we can call other cluster. So Hadoop cluster, we think about is regulated by Hadoop framework. Okay. If you guys see here, in the Hadoop cluster, also we call the computer as a node. Okay, 1 node, 2 node, we have 8 nodes here. Okay, so that's the important concept. So node. But that's for the single machine, we call the node. If a Hadoop processor, an application, we generally call that is services. Okay, a services generally is mean they are run all the time on the cluster node. And also input, deliver, accept input, deliver output through the whole network. In fact, this node, we have classified these nodes as 2 types based on the process they run. Okay, one we called master node. Okay, master node. Another we call the workload or slave nodes. We generally classify this one. That's based on the process they run on their machine. But all of them are computer nodes. Master nodes, workloads. For the master nodes, we can say, these nodes run coordinate services or coordinate service. In fact, some programming or some software can regulate the whole network. They will be stored in the master node. Okay. Also for the user, generally the master node is the access point. Okay. For example, if you want to input data to the whole cluster, you generally through the master node. The master node can be the heart or the brain of your body. They control other workloads. But generally, it's not just one master node. There are several. Okay. For the workloads or slave nodes, which generally is occupy the most part of the cluster. Okay. They will run services that are accepted from master nodes. For example, master nodes have some service want the cluster run. They can sign to this workload. They can sign to this workload. Also, they can sign to this node. Okay, that's from what I talk about at first. The master nodes can assign the service to different workloads. Okay, that's from the general idea. We say the nodes can be master nodes and workloads. But we talk about specific framework. For example, we talk about the HDF architecture. Okay, the workload we can say is just data load and some name node. That's from the HDF structure viewpoint. Okay, this becomes this one. For the name node and the second node, we can say these two is master nodes, and the other data node is just working nodes. In the future, if from the yarn viewpoint, this data node we can call is some other name, and the master node can be called some resource nodes or something. We will talk about more later. Okay. Currently, we just talk about name node and data nodes. So if we talk about name nodes and data nodes, that's from this viewpoint. Because you have a network cluster, okay, we can store the data on some nodes. So this kind of nodes we can call the slave nodes, workloads. Then also, if they store data Locally, we can call them data loads. What's name node and second name node? Okay, name node and second node, we can treat it their master loads. Majorly, they can regular other data loads. Okay, in many design, the second name node and the name node, they can be in the same machine. Okay. So what's the real role for name node? Name node generally store the directory tree of the file system, file metadata, and the location of each file in the cluster. That means if you want to find some file, first you must through the name node, because the name node has the directory tree of the file system. They will then know the location of each file will be in this name node. So if you want to find some file in the specific location, first you give node, go to directory, okay, to find the location of the file. After you found the location of the file, then you can go to the specific loads, okay, to get the data. The name node is the same, it should be similar as a content table in your book, okay? The data loads is just some chapter. So first you want to find which table, you can go to the content table to find this chapter, where is this chapter, where is the other chapter. That's name node, okay? But we have another concept called the secondary name node. What does the secondary name node do? We will talk about it later. Secondary name node is not the second name node not the copy of the name node. Okay, we will talk about more details in next several slides. But first, we'll talk about the data loads, because just now we have data loads here, second node here. Okay, so the data loads just store and manage HDFS blocks on the local disk. That's there is one that missed. Okay. Also, the reports here and the status of individual data stores back to the name node. Okay. That's the data loads is the really computer who store the data. Name node is not a general name node will not store the data. The real data. They only store the directory tree of the file system. Okay. What kind of data? What's the name of the data? The location of the data. Which data loads have this kind of files. So that's the difference between name node and data loads. See here. So you guys generally HDF cluster can be have one name node, one second node, and the number of data loads. Sometimes the second name node and name node, they are in the same machine. Okay, but the data nodes can be in other machine. Even sometimes this machine also can be saved as data loads. That means this machine can be name node, can work as a name node, can be a second name node, also can be treated as data load. That's when you design the network. If you want to make a very big network, that means you have to use several machines. You use the one machine for name node, one machine for secondary name node, one other machines for data loads. But your machine is very small. Your network is very small. For example, you have 3 computers. Then you can put one computer is a name node, second name node, and another 2 is data loads. That's one. Also, even you can use this machine as a name node, second name node, and data load, and the other 2 also data load. That means you have 3 data loads on the 3 computer network. okay, and one name node and a second name node, because the name node, the secondary main node and the data node can be in one machine. So for this machine, you can if you put the data nodes here, for example, some people can like this way. I could put the this one can be data nodes, this machine. Okay, so that means all of these data nodes is just a slave nodes or work nodes, but this machine can be a master node, and also it work as a slave node. Okay, because it's also we can treat it a data node. Depend how you design the framework. So let's talk about the secondary. What's the secondary name node do? Okay, just now we know there is a name node. In fact, originally they does not have the secondary name node. Just have the name node. Name node, in fact, if you guys see in the ring node, they have two things. One is called F's image. Okay, F's image is the snapshot of the file system when name node started. So when you start the name node, then they produce a S image on the name node. Okay, that's one. For this, the FS image just include the whole information for the file system. Also, there is edit logs. Edit logs is just the sequence of changes made to the file system after the name node started. Okay, that means what? That means when the name node start, then we create a F's image. Also, there is edit logs. Edit logs just means it's already started. That means if there is change about the whole system, okay, the change information will keep in the edit logs. For example, some machine is failed, then also they come to the edit logs. Also, there is other things they changed. So first, they don't have the secondary name node. So there is one thing that happen. When they does not have the second nodes, so the edit logs generally will growing very large, because every time when you have some change, they will put in the edit logs. Okay. So if the edit logs is bigger, generally you know the file is bigger. That means it's difficult to manage. You know, that's the first things when the name node running. The second thing is when the node stopped and restart. Generally, they have these things. They will use the edit logs to modify the name node. Okay, because there is some modification of the whole system. This modification should be merged to the FS image. So generally make the restart of the name node takes a very long time. Okay, so that's the two things first happen. One is the restart of the name node takes a long time if you once you stop, because it merged the edit logs to the F's image. Another thing is the edit logs, if you don't modify it during the name node is starting, the edit logs is become very big. So that's also not good. Okay, every time it have logs come. Make the files bigger. Definitely it's not what you want to do. So another thing is sometimes there is a crash. Okay, if the machine is crashed, the edit logs the information perhaps lost, but your F's image is not modified, because the F's image include everything the name node have. Okay. Once since your name node crashed, perhaps the SF image is lost, edited logs also is lost. Then what you can do? So we need the copy. The first thing is we need a copy for the F's image. This copy should be not stored in the name node, because the name node is supposed to crash it. If you crash it, I cannot find something to restart my machine. So we need a copy to some other name node. That's first thing. The second thing is I want to reduce the size of the edit logs when the name node is working. Because if you don't reduce the edit logs, that means the size will be big. So the only thing is we can modify the F's image real time. If I modify this F image, then the edit logs can be removed, can be give away, throw away. Okay? That's the reason why we need a secondary name node. So secondary node work like this one. For example, you have name node, second node. First, when this machine is start, okay, they create a first image. Okay, the first image, first they will copy one first image to the secondary name node, and also copy that's the first thing. Okay, when you copy the F image to the secondary name node, okay, then even this name node is running, I can use my second name node to merge the edit logs into the first image. Okay, after I modified the F image with the edit logs, then I copy the updated F image back to the name node. So it does not really affect the name node. Everything work will be done by the secondary name node. Okay? So every time the secondary node will query the edit logs from the name node. Okay? I get the information from the edit logs, then I modify the F's image in my machine. After that, I copy back to the name node. That's the second node do. So think about this one. That's why is I can, if I get the edit logs information and I already modify the F's image, so I can remove the information I already used in the edit logs. So the edit logs will become smaller. Some image can slow away. That's first thing. So the edit logs will not become large. Another thing is, if there is a crash of the name node, I already have F's image here. Even this F image in the name node is destroyed. I still can copy this one, store in the secondary name node to back to the name node. Then it still can recover the name node. Okay? So that's the basic idea for the secondary name node to do. But the secondary node is not do this exact same as the name node. So that's you guys need to know. We already talked about the Hadoop distributed file system. Hadoop distributed file system is amazing response for storing data of the cluster. Okay, the basic idea is first, for example, we need to store the data files. Generally, the data files are split into blocks and distributed across the nodes in the cluster. For example, you have a big file. They can make it to some blocks with some MB. Okay, the fixed MB. For this machine are still 3 blocks. Another machine, another 5 blocks. Another machine, 1 blocks. They can just based on the system to store the blocks in different machine. But if you guys think about this one, if for a single machine, 1 machine, so the whole file you store for 1 machine. But in the HDFS, the 1 file, okay, different blocks can be saved in different machine, not just 1 machine. Okay, that's the first thing. The second thing I talked just now, the Hadoop system, they store the data multiple times. That means one block is replicated in different machine. For example, one machine same block, this machine store this block, another machine store the same block. Because even one machine failed, I still can get the data from another machine. So sometimes we can say the Hadoop system is redundant. It's redundant. Okay, redundant sometimes is good it's safe to keep your data. Okay. In fact, the Hadoop HDFS is a file system written in Java based on Google's GFS. Okay, so that's the system. There are some other concept in the HDFS. The first thing is just that we just talk about it for the blocks. Generally, the blocks I remember is about 100 MB. Okay. That means one file is big file. You can divide 5 or 6 blocks. So 6 blocks. Each block is 100 MB. Another thing is files in the HDFS is write ones. Okay, and also it's a stream reading. Stream reading just continuous reading from out, not written reads. Written reads. You guys can find the written reads from the Google. Okay. Stream reading just means you can continuously read the files. Random reads, that means you can get some blockers, any blockers I want. So how far to store? I just show a basic idea. For example, we have one input file. Okay, if you guys see, we have 5 machines, 5 rows here. Okay, think about this one, the 2. First we divide the input file to 5 blocks. Okay, 5 blocks. Each block we can say is 100 MB. So a file we have 500 MB space to store this data. However, each block will store 3-fold. For example, to this block, in machine A we have 1 copy. Machine B we have one block. And machine D, we have another block stored there. But these 2 are the same, exact same things. So when the machine A crashed, we still can get the block from machine B and D. Even machine D block crashed, we can get the block 2 from B. The same from 1. Block 1, we can have copy here, 1 copy here, and 1 copy here. For 3 also we have 3 copy. 4 have 3 copy, 5 have 3 copy. That means the storage in this system is redundant. Okay, that's the first thing you guys need to know. It's redundant. We have multiple copy. That's the for the data storage. For the for the data management, for example, how the client submit the data. Okay, how the name node to do. In fact, the master name node just keep track what blocks make up a file, because your blocks are stored in different machines. So you need some people to track these blocks for one file. Then I know, block 1 is from file 1, block 2 is from file 1, block 3 also is from file 1. So when I want to access this file, so the name node will know, get these blockers from different nodes, then give you a whole file. They will not give you a block. Okay? So when you retrieve a file, they will be retrieve the whole assemble this block to one file to your client. Okay? So that means we need a name node. One is track what blocks, another is where are these blockers. That's important. So generally the name node will be communicated with the data loads, which hold the data block. Because the data loads who holds this data block is data loads. Okay, so the name node need to communicate with them. So when the client want to access to read a file, it first requests the metadata from the name node. Say I communicate with name node first. I want to file called mtu dot some blah blah. But the mtu dot, they are stored in different machines. So name node will communicate with the data loads, okay, to get brokers, then assembly them to one file, then give to the client, okay. But for the read or assembly happen, they will be in the application. For example, the application generally communicate directly with the data loads to read the file. Okay. For the data loads, they just give the application this information, how to assemble it, where and what this kind of data located. So the application get this one. They will communicate with the data loads, okay, to get these brokers. If you want to read the whole file, they assemble it to you. Okay, so that's got the data management in the HDFS. Now let's talk about something about YARN. In fact, YARN, in fact, the full name is Yet Another Resource Negotiate. In fact, it is cluster management technology. In Hadoop version 1, we don't have YARN. Okay, it's only come to in Hadoop version 2. Originally, Hadoop can be say a redesigned resource manager, but now it's characterized as large-scale distributed operating system for big data application. In 2012, YARN became a sub-project of the large Apache Hadoop project. We call it MapReduce 2.0. In YARN, in fact, they decouples MapReduce resource management and scheduling capabilities from the data process component. We will see this one in next slides. Also, the YARN enable Hadoop to support more varied processing approaches. For example, many applications such as graphic processing, machine learning, and other memory-intensive algorithms were not supported by MapReduce 1.0 version. But in MapReduce 2.0, that is YARN, they support machine learning, graphic processing, and a lot of other intensive algorithms. That's the different from MapReduce 1. So this is show the architecture of YARN. In fact, in the architecture of YARN, we have a resource manager. Okay, the resource manager generally are stored in master node. Then also we have some non-resource manager called load manager. The load manager have a bunch of load manager. This kind of load manager are generally stored in a data load. Okay, so that means they are stored in the slave loads. So also for the load manager, also we know for some machine there is a containers. Let's explain this kind of concept. For the resource manager, generally, it keeps track of live load managers. They will manage this kind of load manager. Okay, we have a bunch of load manager. They were managed by the resource manager. They will know this load manager is working or not. It's start or not. That's the themes. Okay. Also, they will keep tracking the available resource. For example, how many containers available in which loads. Okay, and which nodes, how many resources is available. It is already occupied by some task. That's one. The second thing is also if some client and submit some application. For example, there is a program want to executing. Okay, so the resource manager will send which load will execute the application. Okay. And locate the available resources to the applications and its task. Also, they will monitor the application master. What's the application master? In fact, for each application, the client submitted. When you submit the application, they will create a application master. Okay. Application master. This application master is specific for a specific application. Generally, we can the application master is regulate this application. For example, you submit one programming to do face recognition, then they will create an application master for the face recognition application. Okay, so this application master, they will coordinate the execution of all the tasks with the face recognition application. If I have another client submit another web analysis application, then the resource manager will create a web application analysis application master. Okay, so this specific application master for web analysis will coordinate the execution of all the tasks which will be used to finish the analysis of a website. Okay, so the web application, so the application master is just will be created for each application submitted by the client. Okay. In fact, the application master will also ask for appropriate resources containers to run tasks. So that's the basic concept. For the load manager, in fact, they generally they will communicate with the resource manager to tell the resource manager what the resource is available. Okay. Also, another task is to also they are communicate with the container. Okay, they provide this kind of resources for some application. For example, face recognition application, how many containers they need to use. The load manager will provide this kind of sources and manage the process running in this kind of containers. They can kill some they can kill some start some container. What's container? Container, in fact, sometimes we can say it has we can like this one. It's just can be with some RAM memory and CPU things. Just a rack. Okay, it's similar to some one small computer. Sometimes you can say, oh, this is very small computer. Okay, it's one container. Okay, in this small computer we have some CPU, RAM can be assigned to some application to execute some task. Okay, Generally, for a node, okay, there are several containers. For example, here is we have 3 containers. This one have 2 containers. This have three containers. Okay, so that's the important things you need to know. So if we know this kind of concept, that will be much easier. Okay, I already write specific details here, so you guys can read them carefully. Another thing is how the application really run in the YARN. Okay, the procedure is like this. A client first they run some application. Okay, I will sub some application to the resource manager to request the resource manager to manage my application. Okay, that's the first step. The first step, the resource manager will start some application master. Okay, this application master will coordinate the execution of the application the client submitted to it. Okay, start the application master. Generally, the application master we call the AM. Also, we need some container to run this one. Okay, the container will run this application master. So when the application master run, they will negotiate the resources with the resource manager to say how much I need to run the task in this application. Okay, one application perhaps have a bunch of tasks there. Okay, then they will talk to the resource manager. So resource manager say, oh, this application. Okay, the task is priority is 1. The location is host 1. The host 1 will execute this task. What are the resources I need? I need 1 GB memory and 1 core, 1 CPU. Okay. Total content, the number of the container is number 2. Okay. Because one loads perhaps have 2 or 3 containers there. Also, there is another application. We put the priority there is 2. Okay. So the location is rack 2. Okay. Then the resource will be there, and the number of container to run this task is number 1. Okay, so resource will do this one. After the resource do this one, the resource then the resource manager after do this one. Okay, for example, they say this task will be run by some container 1. Okay, first they will find the machine who can run this application task. Okay, then collect that computer. Okay, then I found the number of the containers. Okay, then I found the resource is 1 GB plus 1 core. Okay, then we can put a task on that container and let it run. Okay, at the same time in the local there is a node manager. Okay, to manage this kind of resource, they provide the container to the application. Okay, another thing is they also monitor some container whether they finish or that. If some container cannot run, they kill it. Okay, this kind of information they will send it to the resource manager by the node manager. Okay, so that's the basic idea of this of the YARN can do. So what we talk about is the just now we talk about it for the Hadoop cluster which implement HDFS. Okay, that's we know data loads and the second load name node, also name node. But generally you guys know if we Hadoop cluster also we have YARN, the structure will like this one. Generally data node they also store a load manage. Okay, so here is load manage. Data load, store a node manage. Then the second load is here, name node is here. Generally, we also have some resource manager. Okay, so the resource manager, second name node, and the name node. These 3 we can treat it as a master load. Other this kind of stuff is just workload node. Also, we call it slave load. Okay. In this kind of structure, in fact, the resource manager, secondary name node, and name node, they could be run in one machine. The structure will like this one. Okay, see here. Yeah. Okay. This one, the resource manager, also we can just need to be a load manager. Then the resource manager, second main node, and name node, all of them can be in one machine. Okay. Others just the slave roles. Even sometimes on this work row or this master road, sometimes also we can create make it as a data node. Okay, if we make a data load, sometimes also we can store the node manage on this machine. That's one machine can store a lot of things in one machine. But for the bigger cluster, generally we don't do that. Okay, for small cluster, for example, you just have 5 machines. You can make this machine to run the resource manager, name node, and the second node. We don't need we don't need to run these 3 things on 3 machines. That's waste the resource. Okay, so that's for the talk today.我靠你妈的，他妈的没有。